Introduction to image analysis. So in the next 45 minutes to an hour, we're going to try to cram everything you need to know about image analysis in ArcGIS into one session. And I hope everyone's in the right spot. If not, hang around, hear about imagery, why it's cool, and why you should be using it in your workflows going forward. So my name is Yuri Patalski, and I'm joined by my colleague.
Hey everyone, I'm Cody Welch. I'm a solution engineer on our imagery team alongside Yuri. So it's great to be here, and like Yuri said, let's have some fun with imagery today.
So to start out, I just wanted to show a few images of imagery. And I guess we could kind of group these into their similarities and their differences, right? So they're all taken either from a satellite or some suborbital plane, traveling across the Earth's surface, taking imagery, or in some cases, drones. And although they fit into that general category, what we can see that there is a ton of variation, and a lot of that is related to geography. So where was the image taken, over what geographic extent? But there's also things that the sensor, when it's capturing that imagery, may be better at extracting or maybe operating in a different wavelength. So some may be great at analyzing data to create land cover or extracting healthy vegetation, and some may have a better spatial resolution than another. So imagine if you were to draw a pixel of that data set on the ground, some are more exact spatially than others are. But they all fall into this general category, right? They're all imagery. So what's really cool about that imagery is what we can do on the back end. So on the analysis piece, which is what's going to be the focus of our session today. And this was the image. These are the exact same images I showed in the previous slide. But what we can see here is we've taken this high-res, in this case RGB orthophoto, probably from a plane, and we've extracted land cover from that. So that's just one thing that we can do with analysis. If we're interested in forest cover or interested in the amount of impervious surface that is in an area, that's all stuff that we can extract from imagery. This is the Ohio River in Kentucky. The upper left image, we were just taking out various land cover. In this case, I believe it was agricultural or urban. And in the bottom left corner, we're actually categorizing different land cover types. So this is categorical information. We want to know where the forest cover is. We want to know where the open water bodies are. And so we can extrapolate and extract that all from imagery. If we're trying to do stuff on the more deep learning side of things, or artificial GeoAI, if you will, this is a city very different contextually than any of these other locations that were on the slide previously. But what we can do is we can actually train models to go in and pull out, in this case, buildings. So this is a model that was trained on a specific region or a specific geography, and it extracts that data into your GIS. Similarly, we're doing almost a cookie cutter of the exact same example between these two geographic regions. And what we can see is that we can also get at the information for this landscape in Sweden. Very different. We have a lot more vegetation. Again, contextually or spatially, it's a very different area, but we're getting at that exact same information just through two mediums. And this is the Permian Basin in Texas. So this was a deep learning model that was trained to detect well pads. And again, you can see it's completely different, the imagery, context, geography, than all of the other ones or the other areas. And we can take that model, we can extract those well pads. It's just like we were doing for building footprints or swimming pools or anything that were discretely geographic features that we're interested in. And in this case, it's kind of challenging to see, but we've built a space-time model so we can actually study how that landscape has changed over time. So if you're familiar with multidimensional data, that's another really amazing thing that you can do with imagery, and particularly image analysts or the analysis piece is we can generate these essential data cubes. So you think you have 15 data sets over varying years or months or some phenomena, and we're actually creating an image stack. But we have access to all the pixel level information for that entire stack. And so in this case, that's what we've done. How has that changed over time? How has the number of these features changed? Have they increased or decreased by region or type? So we can do all this with image analysis. Another example would be if we're trying to do a suitability analysis or a suitability model. These don't happen in a vacuum, right? We're not just dependent on one data set. So in this case, we're taking all of these data sets and we're combining them into an output analysis. So, and this could represent anything. In this scenario, we're talking about flood risk, rainfall, temp, slope, and NLCD, if you're familiar with, that's the National Land Cover Data Set that USGS puts out for the continental US, land cover data on a pretty consistent cycle. We can combine all of those through spatial analysis, and we can get an output suitability map. But this could resonate with a whole host of projects or workflows that might be custom tailored to what you're trying to study. And down in the bottom there, we can scale this out. So if we were running this on a specific time interval, or we had more data in this case, continental US, really large data sets, we can actually use ArcGIS Image Server to scale that out. So think about if you're doing stuff in Pro through image analysts, you could do this analysis, but if you needed to do this with any regularity, you could create a model, fire that model off, and use the power of raster analytics to do these batch jobs, these kind of larger processing jobs. In this case, it was a 30-meter output. Kind of another very similar but different is this kind of the idea of riparian vegetation assessment. So we have not only imagery data, that's what I've been focusing on up until this point, really, but we have all of these other data sets that can make a more holistic picture about that analysis and complement what you're doing. So in this case, we started with some worldview imagery of pretty high, medium resolution on the far left. That's just a satellite image, essentially. And then the two intermediate data sets here in the middle are using LiDAR to first create a bare earth model. So we're removing those trees from the surface, and we're actually just getting at the terrain. And then in the third, we're actually just taking those first returns. So if you're familiar with LiDAR, sensor flies over, bathes the surface of the earth with laser pulses, essentially, and captures how long it takes for that to return to the sensor. And you can do a lot of really, really unique, cool stuff with LiDAR. One of the things is creating these digital terrain models, or digital, in the third example, or a digital surface model. We're interested in those trees, in this case, because it's a vegetation assessment. And we can also take vector data that we already have or have collected in the form of stream data. We can combine them, and then we can actually see across that surface in the upper right corner where there are areas that may need attention as far as riparian health, where are the areas that are within the means or the confines of stuff that we've set out, parameters essentially, and areas that might need plantings or might need some or areas of interest that could use work as far as this analysis goes. So I just kind of wanted to set that stage up front with some examples of what you can do. And this is just kind of a rough agenda of what we'll cover. The first is this imagery system overview that I will be talking about. And then Cody will be talking about back to basics, kind of raster 101, and also the raster functions and the analysis piece. And then I will pick up again and talk about Python and the APIs to close this out. So if you've attended any of our imagery sessions, I'm sure that you have at one point probably seen this slide. I'm going to go it contextually in turn here. Obviously, we're focusing on analysis, but I kind of wanted to show how ArcGIS is a complete, comprehensive imagery system from start to finish. So first off, content. Not only data that you would have, we support a variety of formats natively, but there are also other third-party vendors that provide satellite or imagery data. There are a lot of data and pretty large holdings that we have in the ArcGIS Living Atlas, if you're familiar with that. We have a ton of satellite-based, we have SAR-based services on there, which is radar, and I would encourage you to go check that and explore that to see if there's anything that could complement what you're working on. And again, various content providers and your data. So you're bringing it into either the desktop with ArcGIS Image Analyst, SAS, which is ArcGIS Online or ArcGIS Image for Online, and then we have Image Server or Image Dedicated at the enterprise or server tier. So once you take that content, you need to manage that content. So we have a variety of tools. If you're familiar with the Mosaic data set for managing that, we have a variety of direct read for other data types, and you can publish hosted imagery layers to ArcGIS Online, and we support a wide variety natively of both satellite that comes from vendors with metadata, as well as data that's elevation. In the case of the riparian data set or workflow, any of the LiDAR data, we can read all of that natively and bring that into ArcGIS holistically. Reality mapping is a new suite of products. It's kind of a unique in kind of our imagery holistic system, is that it's not only a series of products, but it's a series of capabilities that roll up to that product. So anything with drones, drone to map, site scan, anything, and then the reality products for Pro and Studio, anything where you're trying to capture satellite or drone-based data to create three-dimensional representations or base content for your GIS would be done through reality mapping. Kind of out of turn here, but the final piece is visualization. So we really want to take all of this data, once we've run analysis and we process things, we want to provide a visualization experience that resonates with as many users as possible. And this is in the form of custom applications that you could write, in the form of dashboards, anything in ArcGIS Online that you're creating content and how you're sharing that. This also, on the other hand, is all the visualization techniques in ArcGIS Pro and across the technology stack. Temporal profiling, any of the raster functions that Cody's going to talk about, and just kind of creating a comprehensive picture. But why we're here today is to focus on mainly the analysis piece. And we'll run through a whole host of things, but some of the major kind of large big ticket items are performing classification, both through a machine learning lens and a deep learning lens, change detection with kind of the multidimensional data, raster analytics that I mentioned before, kind of raster analysis at scale, and GeoAI. And ArcGIS Pro kind of focusing in on ArcGIS Pro as a product suite. These are kind of the flavors. We talked about reality. Image analyst is where the majority of the functionality that we're going to talk about, kind of the bucket that it falls into. But you have access to raster functions, and as well as, if you're familiar with another extension, ArcGIS Spatial Analyst. So that's another complementary product. And ortho mapping, which is actually available with just an advanced license of ArcGIS Pro. So if you're doing collection and you're trying to do block adjustment and create ortho photos or ortho mosaics, that's an option that's default in Pro. I think this is last slide I have here on this section, but we really are continuously trying to improve the supportability of platforms or data types. And we've had a lot of additions this year. One thing is the trajectory data set, which is capturing altimetry data from sensors, from satellite platforms as they go across and collect data. It's kind of similar to the Mosaic data set. It's kind of a data model for managing and using that data. We released the SAR tools earlier this year, so anytime if you're working with any kind of radar data, we support Sentinel-1, ISI, and RCM, GRD data. So that's another option for using image analysts, bringing it into the platform. We're always working on deep learning and extending that functionality. And then we have a newer offering that we really won't talk about exclusively here, but is ArcGIS for Microsoft Planetary Computer. So you're bringing the power of Pro into the cloud next to the data to try to exploit it that way, and current API enhancements. With that, I'm going to turn it over to Cody, and he is going to talk about back to the basics.
Thanks, Yuri. So as we're talking about today, we're talking about raster data and image analysis. But really, what is a raster? How do we understand that if we're not familiar with that? So that's usually data that consists of a matrix of cells, or as we call it, pixels. And these are organized into rows and columns that are grids that represent a data value within each pixel. And these can be aerial photos, imagery from satellite, pictures, scan maps, and even more. So I know we keep saying image analysis, but ultimately a raster can have these same types of workflows applied to it, even if it involves, like Yuri mentioned, SAR data or frequency information. You can apply them because ultimately it's these matrix of cells organized by rows that make up that data set that we're going to exploit. And so some of the key things to consider when we look at what a raster is are 4 key components. The first is going to be the spatial resolution, or the cell size of that raster. This is very important because the spatial resolution determines how much data is in each pixel. So whereas something like Landsat will have a very large pixel size, or like 30 by 30 meters, there's a lot of information in that pixel. Whereas a drone can get really high accuracy ground sampling distance that is down to somewhere around an inch or less. And so it has a lot more information in there. And so you can start to make more detailed analysis because you have that level of resolution embedded into that raster or image. Next is going to be your spectral profile. And that breaks down into what we can see. So usually with imagery, we're looking at RGB, or red, green, and blue bands that our eyes can see. Landsat sensors, things of that nature. When we get that data in and we see the image, it's typically in red, green, and blue. However, we can support additional sensor types that expand upon the visible spectrum, such as SAR, things like that cut through the clouds, and so you don't have to worry about actually seeing the RGB image with clouds in it. You can bypass that and start to still do analysis on those products because we support those spectral profiles as well. There's also the temporal aspect of raster data. which is the frequency of the capture. So not every raster data set has to be a single picture. Like we mentioned earlier, multidimensional data sets allow us to have time slices, stacks of data that we can actually analyze over time and start to find change, things of that nature that we're looking for, and identify those over a series of time or the frequency in which it was captured. And then lastly, the radiometric resolution of a raster, which is the depth of the pixel, how much information is stored within that pixel. Examples of this would be like an 8-bit raster or a 16-bit raster, 32-bit floating point. All of these vary based on the sensor that collects it, but they all can allow for unique analysis to take place. So I know that was a quick overview of rasters, and there's a lot more to them and what we can do with them. But let's go ahead and jump into how we can actually start to analyze this data within ArcGIS. So as we've already kind of talked about, we have a lot of tools to process our imagery. And we can do this, these analysis for any type of user. It just depends on what your application is. This can be, importing the APIs like Yuri's going to talk about later in Python and writing our own scripts to do this. We can do this with raster functions and Python, like we just mentioned. So we're going to take a closer look at raster functions in just a second. And these allow us to process the imagery and create derivative products, whether that be persisting data using geoprocessing, which we're familiar with our geodatabase tools. So we can, if we're leveraging image analysts as an additional set of tools that we can start to really exploit the data with and write out new foundational content that we're creating and curating. Or we could apply raster functions, which are extremely powerful because sometimes we need to run analysis that we don't want to derive a new product from, but we want to be able to see it quickly so we can share that visualization within our organizations and not have to write new content every time. With ArcGIS Image Analyst, you can expand upon the embedded raster functions within Pro and do things such as overlay, statistics, and math, and then continue to bring out more and more information from your data sets that really enhance your image analysis within your ArcGIS system. And so lastly, we're just going to touch on a few of the key models that are very important when we talk about doing imagery analysis within ArcGIS. These key models, we've already talked about the single raster data set, the product or the derivative that we just mentioned, the mosaic data set, which is the framework to help us organize our imagery and maintain it and have a management system like a catalog of our imagery that we can attribute, apply processing templates to, and do these things at once over a bunch of images instead of just one. And then image services, where we take those products or those mosaics that we've created locally and then share those into our organizations, whether that be ArcGIS Online or Enterprise, so we can share with our stakeholders the information that we've unlocked from the pixels that we've interacted with. And some of those fundamental tools that we're going to use today to get through this will be our imagery analysis tab, our GP tools, our geoprocessing tools, raster functions, and see this over time. So when we start looking at this, guys, where do we access all this? We can do it through three main ways. Through ArcGIS Pro using Image Analyst. We can also do this with the SaaS offering of ArcGIS Image for ArcGIS Online, which allows us to extend our workflows in your online organization and leverage the same raster functions that you're using locally within ArcGIS Pro and Image Analyst. So you are extending this out to the larger organization. And you can also leverage this through ArcGIS Enterprise using ArcGIS Enterprise with Image Server to allow yourself to share those on your on-premises deployments if you need to leverage image analysis at scale and take that server-side processing with it. And as we'll see later, we can also start to automate and use the notebooks and APIs to really do this at scale. So let's take a first step and look at what image analysis in ArcGIS Pro looks like. So I'm going to stop sharing here and bring up ArcGIS Pro, and what we see here is I've got a project area. Using aerial imagery from our partners at Vexcel, we're able to start to exploit this image and learn something from it. So to set the stage for you guys a little bit about why this area of interest was chosen, is this area has a high karst topography makeup, meaning that there's a lot of sinkholes and the river is cutting through, so the watershed could be big, and we want to understand, can I use this one image to start to derive my watershed, to find out what parcels within this area of interest have the most risk to it, and how I can visualize that back to my end users. So what we see here is we have our image. This is our RGB that we were talking about where we're able to look at it. But as we mentioned earlier, this could also contain surface information. So here's our DEM of our area of interest. So we're seeing our elevation model. We can quickly symbolize this by looking at our symbology tabs to be able to change those if we want to. And here we have it symbolized by elevation, so we see the highest and lowest points within our image or our area of interest we're looking at. We'll say I want to quickly understand what the slope looks like, but I don't want to write a lot of new data. So this is where we can start to really start seeing the power of raster functions, and let's do that now. So what we've done is we've activated our DEM, and when we do so, we can see that the imagery tab becomes active. And seeing that we have image analyst enabled, we now have the ability to work with the pixel editing functions, classification tools such as deep learning if we want to start to automate, change detections, and here we are at our functions, our raster functions that we've been talking about. So I'm going to click this, and when we do, I can see that I have a system toolboxes of raster functions already available to me, and I can expand those, and these all generate on-the-fly products. So there's no rewriting data, but you can quickly apply these to your functions or to your data, to these functions to your data to be able to quickly visualize something. So there's quite a few here. In our case, I want to understand the slope of this area of interest. So I'm going to click surface, and here I can see that we have a bunch of surface tools already available to us. So I'm going to click slope because I want to see what the slope looks like and get a better understanding. I'm going to select my DEM. I have these default settings that I can change or leave. In our case, I'm just going to leave it. I'm going to hit create layer, and that fast I was able to render out a slope visualization of our DEM that can then be interacted with to say, well, I don't really see that very well, so let's go and change our symbology again. It starts to act just like a persisting data set that we're already working with, but this is all being done on the fly for visualization so you can really start to understand what we're looking at. And I did not mean to click the first one, so that should look a lot better. But here we go, so we've got that. But that's cool for one aspect of looking at one image and one analysis product. What if I want to start doing multiple products at once or steps in my workflow at once? If you're already familiar with Model Builder, we can do something very similar with the raster function editor, which allows us to open these up. And now say I want to actually find that watershed, I can start to chain these functions together to create my own workflow, just like Model Builder. So in this case, we might, we just did slope, so we could drop our slope in. But then we would go up into our hydrology tool sets and say, well, now I need to understand what my flow direction is. So I drag that in too. But what if I needed to fill sinks before that and I realized, oh, I didn't do that first. And if you had already written that product, you would have to start your workflow over. But with raster functions, I can just drag that in front of it now and then connect it to my slope raster, just like I'm chaining together a model in Model Builder. And so we can go through any workflow that we can imagine and start to put these together to create these models of our workflow. And so in this case, I've already done one for our hydrology analysis. So what I'm going to do is expand it. These are all saved. So I could come in here now and open up our watershed one. And then I have the ability to simply quickly run that to derive our output. And what we get when we do so is we will have our watershed derived for us just like this based on our raster function that we created, because what we've done is chain the workflow together. So if I drag that in, what this would look like is this. So I'm going to get rid of those first couple that we just had. And from there, we can now see that this is the model that did our entire workflow quickly for us to visualize what the output watershed boundary looks like. So now that we've derived that, we can start to supplement that data with additional data sets. Again, finding one thing out from imagery analysis is great, but what happens when we start to pair that with additional data to continue to find out more and more information? So in this case, we have our watershed. I'm going to go ahead and close our raster functions here. We have our watershed in our DEM, and now we're going to start looking at, well, we said that this is a high level of karst in this area. So what about all the sinkhole data? There's that laid in too. So now we're supplementing our analysis with our vector data that we have. So now we've got both. But what if I also want to start looking at the parcels that are in this area too? Those are there. Because remember, our goal was to find which zone had the highest risk within the parcels of this area of interest. So as we zoom in, what we can see is that we have the sinkholes available to us that have been identified and buffered. And what we can do from here is then say, using zonal statistics, which is also a raster function or a geoprocessing tool, we're able to then find out reclassify the land based on their use type. So in this case, I'm going to turn off the parcels. Using those parcels, we were able to reclass them using zonal statistics and our imagery to get that information embedded into our polygons. And so we've reclassified these into 3 zones that we can expand and see high, moderate, and low population, because we're really worried about safety of our population if one of these sinkholes was to collapse. And then using a few additional tools within geoprocessing and image analysis, so we would go here to our image analysis toolbox, and we could do our overlay tools. Because what I'm wanting to do is find out, what happens when I pair all of this data together. Because that's how I'm going to be able to understand what I'm looking at. Being able to use those overlays and those classification tools, we're then able to identify the parcels with the highest risk and then find our highest risk zones based off of those statistics. So let's turn off our sinkholes here. And now we've identified the exact spots based on our imagery and the ability to do that analysis where we can start to see it. And what's really powerful about some of these is you can actually see them within the zone from the imagery themselves. So let's zoom down a little bit, and we'll be able to start seeing these sinkholes in our imagery. And we've validated that, yeah, they do exist in those locations. So like right here, we zoom in, and we can see that this is already starting to cause a sink. But that's great. That's a cool analysis that we've done locally, but let's jump back in here and continue to explore where we can go next. Because I did that locally with ArcGIS Pro and Image Analyst, I now want to share this and continue to do my analysis at scale within my organization. And in my organization, I have an ArcGIS Online organization that I'm going to leverage ArcGIS Image for ArcGIS Online and do this analysis within there. But what's really powerful about that is, remember those raster functions we just did? I can share those directly into my organization and continue to leverage that tool to anyone that needs to interact with my data without them having to model that out themselves. They can do the workflow that I've set up for them and continue to derive that analysis using that workflow on different imagery. And that's extremely powerful when not everyone may not understand what these workflows are or how to access the data the same way. And so using Image for Online, we're able to access those raster functions. The tools are already embedded, so we can do deep learning there as well, just like we could within ArcGIS Pro with Image Analyst. And the one key factor that we're doing this with is that we aren't creating tile caches with ArcGIS Image for Online. We're actually creating image services that can be manipulated at the pixel level to derive those insights. Whereas a tile cache is just a static picture, which they're great, but that doesn't help us learn something from the pixels that we're interacting with. And so now that we've done that, let's take a look at what this looks like within ArcGIS Image for Online. So here we can see I'm in my online organization. This is just going to be an add-on license. So all I have to do is go to my organization and assign that to my users. And when I do that and I have my content available, we can start to see that I can publish new layer types. So what we see here is a tiled imagery layer. That designates it from being a static cache. That means that we can actually interact with this data set at the pixel level. And what's really powerful about this too is you can take your data directly from a folder and go to, with Image for Online enabled, you click your imagery layer, that option that you have available to you now. You can go through the workflow of just dragging and dropping this data in and defining what type of layer you want. Both will allow the on-the-fly rendering, and the client side will be used with the tiled imagery layer, whereas dynamic will be on the server side. So for our case, we don't really want to have a whole bunch of processing on our server, so we're going to create tiled imagery today so that our end users can quickly visualize this without taking too much strain on our networks. We can see that we can do single images, mosaics, or multiple imagery layers. In our case, we had multiple imagery, so we're going to do this, and now I can configure that. Image for Online supports a bunch of different modalities and workflows very similar to ArcGIS Pro, and it already has those templates embedded into the drop-down here, so you can pick the product that you want to work with, whether that be Landsat, WorldView 2, Landsat 9, QuickBird, all of that, or just simply raster data sets. You can make these tiled imagery layers. So you select them, configure your properties, and then you can simply drag and drop the folders directly in to start the upload process. And once that's done, you'll have imagery layers created. For the sake of time today, I've already done that. But again, once we've got those done, we can actually see the designation that we've defined and have the ability to manipulate those. So let's jump back into our project here. So this should look pretty familiar. We just did this in Pro. But now we can do those same workflows here by turning on our DEM. So we've re-rendered that. But because this is a tiled imagery layer, I can now hit styles and reconfigure how this looks right here on the fly. So I can do my min and maximum changes, or let's go to %clip and up this a little bit and change our color scheme. And what that allows us to do is quickly apply these, and we can do these different types of styles and different types of options right here within our viewer. And we can even do this by classifications, stretches, and unique values. If we have categorical data, we can work with that there. If we have those raster functions we created, we can embed those directly into our toolboxes. So we start to create custom raster tools following our workflows like we've already mentioned. And embedded are the already supported raster tools, such as what we saw there earlier, such as the zonal statistics that we used, our managing our data, doing our watershed and our overlay analysis. And then we can do deep learning at scale here as well by quickly uploading deep learning models we've created or pulled from the Living Atlas and quickly reference those right here within our online environment to continue our analysis and workflows. So remember we looked at slope. I could come back to our DEM here, make sure it's activated, and click our raster functions here. I can import that because it's a part of my content, like we just talked about. I created it and uploaded it. And once I hit add, I'm able to then quickly click that option and create our product. And so what we would get is our output like this. There it is again, right there on the fly, that we can keep, or we can just visualize for visualization purposes and not actually add into our storage within our environments. So why is this important? Because taking all of this data together allows us to really start to manipulate the things that we want to find and see within our data. So as we were talking, we were looking for those sinkholes. Now we've been able to find it, we see all of the parcels that are affected, and we can really say, okay, now because this is paired with my GIS data, I can interact with that parcel and understand, who's at risk, what types of houses, what types of buildings, and really start to work with those that way. But again, that's great as a web map. How do I share this to my stakeholders so they can see it? And that's where the power of imagery analysis within the ArcGIS system really resonates, because now that we've done our analysis to find those parcels, I can share my stakeholders a story map that references all that data that they just saw, that explains the workflow that we did, where they get the background that they need, where they can see the other zones within the areas of interest that are also affected, and tell that story to our end user without them having to actually manipulate our data. So what we're going to see here is just the full workflow from end to end that basically shows, okay, there's our parcels. Then we're able to go through and pair it with even 3D data. So we've identified all the parcels in a scene, and they're able to navigate that way and overlay point clouds. So the elevation is rendered in. So they see that, yes, this floodplain is within the lowest part of our area of interest. And all of these sinkholes are at risk because of that. And then you can use those overlays to show the risk percentage slope that we derived. All of these tools work in tandem to help us tell the story that then we could supplement with our vector analysis like we see here. So all of the blue boxes are where we identified our danger zones with our imagery, and all of the red bins are just aggregated data based off of the same concepts but using raster or vector data. And what we've done is paired our image analysis with our vector analysis to supplement each other to say, yes, our data findings are authoritative, and we're able to share that out to our organization so they understand it as well. And you can share these experiences, these story maps quickly and effectively. So now, what if they want to move sites to a different location? They can quickly access an experience that allows them to not only understand that area of interest, but pair it with additional tools such as business analysts. So now they know exactly who is being affected by demographic and so on and so forth, depending on what they're looking for. So thank you guys. That was an overview of this at the localized and online levels, but now we're going to take it even further and extend raster analytics through the APIs.
Yeah, thanks, Cody. That was awesome. I mean, you saw a workflow from start to finish, taking data in, really unique ways of not only analyzing that data, but taking it a step further with actually at the presentation or visualization level. So sharing that out in an easy to digest medium for people to understand without having to really have a concept of how that analysis was generated. We can just kind of see that end product. So yeah, I'm going to briefly talk about extending raster analysis through one of my favorite things, and that's Python. And this is just kind of a generic overview, really, of the API experience in ArcGIS. So I'm going to be talking pretty exclusively about ArcPy and the Python API in the context of image analysis. We have a whole host of other SDKs and APIs for the web, for native devices. So this is mainly for doing image analysis. And think about all the stuff that you've seen, particularly with what Cody was showing and what we've been talking about here today. We've actually exposed the majority of that functionality to where you can work with data and create analysis and derivative outputs. We've exposed that through Python, so you can, in a more programmatic way, kind of address these workflows. Again, all the data types, we can support everything that we've seen previously, and just kind of the model builder visual in the middle of the slide, kind of having processes and workflows broken down and being able to address them with Python or automate them if you have a specific task or series of tasks that you want to have in a more automated fashion. I run this series of tools or this series of steps at 8 o'clock on Friday nights when the office is closed. This would be an incredibly appropriate avenue for performing those kind of scheduled tasks. And then empowering end users. So Cody was talking about Experience Builder. That is definitely a great option. Also using kind of the JavaScript SDK in the middle, where we can kind of get at actual cell values from hosted imagery that's published either to enterprise or online. And real briefly, kind of a collaborative spatial workbench is ArcGIS Notebooks. I'm going to pause that. I was going to try to, but it's a lot going on up in that, in the model in the upper right corner, and that's basically going through. It's a deep learning model that's calculating and capturing stressed roads or cracks or deformations in the roadway. So that's just an example of using notebooks kind of in this collaborative environment to take input data, process it, and create output data that goes into your GIS. So it's not just capturing it, to visualize. It's actually being able to run analytics on the back end for that. Notebooks are available in Pro, Enterprise, and Online in the hosted and the desktop environment. So briefly, the Python API, if you're familiar with that, this is really the Python equivalent of being able to work with services-based data. So if you have data in Enterprise or hosted imagery layers or services in ArcGIS Online, this would kind of be that avenue for working with that data. The cool thing about the Python API is you can create these, and I'm actually going to show a really quick demo at the conclusion of these slides, but you can pair that with general Python. So it doesn't have to just be stuff that we've exposed. You can create these kind of unique ways of addressing problems or workflows through just general Python, to Python libraries that you want to make use of. So this is fully supported. We have the Learn module for interacting with deep learning. We have the IA module that exposes all the image analyst capabilities through the Python API. And we can see that we were doing some raster function processing here, and that's kind of falls within that the raster function world that Cody was talking about. I'm sure you're all familiar with ArcPy. This is the library that the majority of the tools in Pro run against or built with. And what's really cool about this is in notebooks at an advanced level, you have access to ArcPy as well, even in a hosted environment. So your data management processes, your vector-based analyses, they can all be called with ArcPy, and it's available in notebooks as well. We can create custom raster functions. Cody talked about the wide plethora of available out-of-the-box raster functions for you. But if you're interested in creating something that is one of the existing raster functions doesn't fit that bill, you can create a custom Python raster function. It's hard to see, but there's a link actually to a series of curated functions that Esri has released onto GitHub. You could take those, you could adapt those, but that's a really, really unique way to bring a custom function into ArcGIS Pro or ArcGIS at large, and then run further analysis based off of different imagery layers in the future. And the REST API, if you're familiar, if you've used any of our mobile applications like Quick Capture or Field Maps, those are all REST API clients. So you have a device that goes out to the internet to some resource and returns some information about that resource. The majority of these functions have been exposed through the REST API for Enterprise and ArcGIS Online, so you can kind of create some custom unique workflows here as well. And they can be coupled with Python. So it's not just the REST API standalone. It can be kind of coupled with the Python API. So real quickly, I'm going to show a demo in a hosted notebook. And this is why I really like this experience, because we can create kind of custom experiences that leverage general Python. So in this case, I've built out a small function to ask us for an input location. So in this case, I'm going to search for Davidson, North Carolina, which is my hometown. And it's going to go out to ArcGIS Online and to the World Geocoding Service, and it's going to geocode that location. And it's going to return an object with the address and the locational information. And so what we can do with that is we can actually take that locational information and we can pass it into the Living Atlas and see what kind of imagery do we have that in the ArcGIS Living Atlas that is found at that location. What are some of the imagery holdings we have that have coverage in that area? So in this case, I build out another one that says, hey, what sensor are you interested in the Living Atlas? We have Landsat, we have Sentinel, we have NAPE data. I mean, we just have a ton of data in there. But in this case, I'm interested in Landsat. So what it's going to do is I built this little helper function, and once we pass Landsat and that location, we're going to get a list back of all the data sets, or in this case, the image services that specify and meet that query criteria. So we have a whole host here that we could choose from, but I'm really interested in this multispectral Landsat. And so this is the actual item ID, and what I do is I take that item ID into this constructor, and it creates an actual imagery layer that I can use downstream in analysis. And in this case, I want to take that and I want to do a change detection between the years of 2018 and 2023. So what I do is I apply a stretch raster function, exactly what Cody was talking about in the UI. I apply that stretch and I create a composite band. This is kind of an image that's created from multiple bands. We put them together and we run an NDVI off of those. We visualize them as NDVI. If you're familiar with this, this is just kind of a really quick and dirty way to extract areas of healthy vegetation. Once we have that, we get an output image. This is all being done in memory. I'm not consuming any credits in ArcGIS Online here. I'm just doing this all through visualization. I have the output. Those darker areas are areas of healthy vegetation. The lighter areas are areas that are not vegetation. They may belong to another land cover category. And we can create an experience around this. I can essentially create a color map function, take the change from 2018 compared to 2023, and let's create an output raster of the areas that have changed significantly in the browser during that time. We can create an interactive map. I can zoom into specific areas. These areas in green are the ones that have experienced significant change between the years 2018, 2023. It's interactive, it reacts. What it will do is it will calculate that on the fly in the map view directly in the hosted notebook. We can also make use of, in this case, I was interested in Sentinel, and this is the Sentinel-2 image service. It's 10-meter resolution, freely available. In this case, it's on Living Atlas. I did the exact same thing. I passed in a locational query based off of that geocode, created an image layer from Sentinel, and then what I've done is I've added it to a map so we can actually interactively with a time slider see how we have a host of selections we could make here. I'm interested in built areas, those areas of urbanization, and I can step through in sequential time from 2018 forward to 2023 about how that land cover type has changed. And it's interactive. We can actually see how it's changing on the fly, all done at the image service level. No data processing, no cost at all. It's just doing this through a combination of raster functions and map visualizations. And lastly, if we wanted to create persistent data on disk, and let's say I was a user and I had an ArcGIS Image Online user type that Cody was talking about with his web demo for online, I can also make use of these functions like land trender. Land trender is kind of a change detection algorithm. Take a stack of images. We drill down through those images to see how that specific pixels or cell values have changed through time. I can run this interactively in the browser and get an output data set on disk. We can see from this URL that it's published it out to ArcGIS Online utilizing the land trender method through the Python API to create persistent data. So it's just a really creative way to interact with data in a browser with really no software deployed. And we are almost finished. Just a few more slides. Kind of holistically to kind of cross the T and dot the I here in closing, really wanted to show this slide as a visual representation of kind of the image analysis footprint in ArcGIS. We've talked at length about all forms of data that you can ingest into the system that kind of start where your workflows are starting, bringing that into ArcGIS, managing it in ArcGIS as well, and then taking these workflows and creating derivative products. Change detection, time series analysis with multidimensional data, performing suitability analysis, like with the example up front with where we took multiple data layers and combined them into a suitability model. Terrain analysis, GeoAI, there's just a whole host of things that you can do, and creating those, using creative ways to create those output products allows you to make use of the entire ArcGIS imagery technology stack. And then of course, impacting decision making and sharing that information out. That's all we had. Please provide feedback in the app for us, and we would love to take any questions that you might have. And thanks for listening to us go through this kind of at a breakneck pace, but thank you for attending. Yes, ma'am.
With raster functions, is there a way to write it to disk if you really like the output?
Yeah, so the question was, with raster functions, is there a way to persist that kind of in-memory analysis to disk? You want to answer? Or,
Yeah, no, that's fine. So that's a great question. So say you like that function product that you visualized. You can quickly right-click it and export that raster out as a derivative product. The thing that's powerful about them is like, I've gone through the workflow of creating something and realized halfway through it that my product was wrong, and I wrote out like, a folder full of data, and then I have to start over. So that's extremely powerful for that aspect, because then I can say, oh, this looks good, I'm happy with this, now I want to keep it, and then I can take that product and continue to feed it through my workflow and continue to create those products that way as well. Great question.
Yeah, they're an awesome way to just do stuff in memory to see if extracting a process to a larger area is going to be the output or successful. So yeah, they're a really good way, kind of that low-hanging fruit of looking at an area, running it in memory. They're quick, snappy. So yes, sir.
For ArcImage or ArcOnline, do people in, say, my organization who don't have the image license, are they able to view, image services that we have published in our organization, or is that limited to only people?
So great question. So the question was, can my organizational members still view the products that I create using ArcGIS Image for Online? So yes, you would need a license to curate your data and process it and analyze it. However, once it's created, you have the power to share that throughout your organization and embed it just like we did. So what we saw with the story map, that's open to the public right now. You guys could go interact with the data that we curated for that and start to mess with it and visualize that, because it's open to the public. So you have full control over it. You just need the license to be able to actually do the analysis and upload the imagery within to that system.
Yes, sir. Yeah, so great question. The question was, the imagery, through the imagery capabilities, through image analysts, do they compare to other software platforms kind of in the remote sensing space? So my response would be yes. I mean, the whole host of image classification, specific algorithms that you're using. I mean, you mentioned random forests. Those are all baked into image analysts, so you can make use of a majority of those algorithms. And really the key, for me at least, the takeaway is that we support a whole variety of sensors through raster products and raster types. So bringing that data into ArcGIS Pro and exploiting it with the image analysis extension is commonplace. That's why we're trying to create an application or an extension that allows you to do all of that. So, but at its heart, yes, all of those algorithms that you mentioned, any of the deep learning kind of things that you would take that a step further for doing image exploitation are there. The visualization piece is there. And what's unique is you have access to the other suite of tools that may not be image focused. It's once it's into ArcGIS, it's in your GIS, and you can use a whole host and combination of tools to get at some type of output product. And kind of a step further on that question is we have, as far as like classification, and if you're talking about change detection, we've built out wizard experiences. So they're kind of curated experiences that will walk you step by step through that process. And we support segmentation and pixel-based classification, and that's a really unique way to, if you want to use the geoprocessing tools and you know kind of in your mind what you want your output to be, that's fine, but we also have these kind of curated UI experiences that will walk you through that process. The other cool thing about a lot of those methods is they're exposed not only at the geoprocessing tool level, they are also available as raster functions. So that's another way to kind of quickly test outputs.
I've got a good question for you from online. The question is, like the notebook example you showed or workflows you showed? Are there tutorials and examples of those available?
Yeah, and actually the majority of that was taken from our Python API samples that are available through our documentation site through developers.arcgis.com. And if you go to the Python API in the web API section, there's a whole host of sample notebooks that you can download, you can tweak with, and there's a lot of really great imagery examples on there, particularly like the change detection and the land cover change. Those were all samples that I actually adapted from samples that were on the developer's website.
Awesome. And I've got one more from online, and the question is, are you able to extract boundaries like shown in the base map into a shapefile or feature class from deep learning? And so the answer to that is yes. So if you grab those models off of the Living Atlas that are already available, their outputs will be object detection. So if you're looking for footprints, they will be in a feature class that represents what it's found within the model. But it doesn't have to be based in a feature class. So say you want to classify your pixels, you could use some of those models as well and actually derive an output that has classified at the pixel level alongside a supplemental analysis that may be a feature class. So you have that ability to pair them both together or separate to get the things that you're looking for out of your imagery.
Any other questions? Great. Again, thank you for attending. We appreciate it. Hope you've had a great conference and continuing to enjoy it. So, Thank you again.
Thank you, guys.